Very good afternoon, my dear students. In today's lecture, we will learn various crushing laws, which are mainly used in mechanical operations. Okay, and they are useful to calculate power requirement of size reduction equipments. Comminution means size reduction of solid. We all know that in mechanical operation, for size reduction, we use various type of cutters, mills, grinders, etc. Okay, and this size reduction is mainly useful in mineral processing, cement factory, pharmaceutical, and chemical industries. Why this comminution is very important, and it requires energy, right, to reduce the size of any solid. So this power requirement or energy requirement is easily calculated by using various crushing laws. So which factors are needful to calculate the power requirement? So initial and final size of particle, material property, and which equipment we have used. So mainly initial and final size, and based on these two parameters we can easily calculate power requirement of any size reduction equipment. So in mechanical operation, mainly in chemical engineering, we focus or we use mainly three laws, crushing laws. First is Rittinger's law, second is Kick's law, and third is Bond's law. So let's understand which are they and how to calculate power requirement using these laws. So first is Rittinger's law. It says that energy or the power required is directly proportional to the new surface area created. You can see formula of Rittinger's law, okay, on my screen. E is equal to, E stands for energy requirement or power requirement, is equal to Kr 1 upon dp2 minus 1 upon dp1, where dp1 is what, initial size of particle, dp2 is final size of particle, and Kr is Rittinger's constant. This Rittinger's law is based for fine grindings, okay, larger size reduction or large surface area increasement. Okay. Next, second law is Kick's law. In Kick's law, energy is directly proportional to size reduction ratio, where E is equal to Kk ln dp1 upon dp2, where Kk is Kick's constant, dp1 is initial particle size, and dp2 is final particle size. So energy per unit mass constant for constant ratio, and Kick's law gives best result for coarse crushing. Third and very important law of mechanical operation is Bond's law. It says that energy is directly proportional to new crack length, where by using Bond's law we can easily calculate power consumption using given formula. E is equal to Kb bracket 1 upon root dp2 minus 1 upon root dp1, where kb is bond constant, dp2 product diameter, dp1 initial particle diameter. Bond's law is based for intermediate crushing and the grinding purposes, and it is widely applied in mineral and cement industries. Now, comparison of these three laws. So, Rittinger's law is very useful for fine grinding. Kick's law is very useful for coarse crushing, is based on size ratio. Rittinger's law is based on surface area, and Bond's law, it gives best result for intermediate grinding or crushing, right? And it is based on crack length. So Bond's law is the most widely applied for the calculation of power requirement of size reduction equipment. Now, industrial relevance. So retingers is very useful for when we require a product in powder form, right? So at that moment we have to use Rittinger's law. Hicks law is mostly applied for the primary crushers like jaw crusher, and Bond's law is mainly used for the secondary crushers such as ball mills or power requirement via work index. Okay, so these all are what industrial relevance of this particular crushing laws. And conclusion of this particular session is crushing laws predict energy or power requirement No single law universal, it depends on the size range, okay, and Bond's law most widely applied in practice. So this is what theoretical part of crushing laws. In next lecture, we will discuss how to calculate, okay, power requirement using Rittinger's law, okay, in detail. ओके मैं आपको नेक्स्ट टाइम मतलब एक एग्जांपल करवाऊंगी जिसमें आपको इजीली समझ में आएगा कि हाउ वी कैन calculate power requirement using Rittinger's law. Okay, I hope this is clear. Thank you.